Hello, I'm Jaden and I'm starting a new channel today. You might see the difference in my hair. All cut. I don't like my hairstyle this way, but it's the only way of haircuts I ever need. Right now, at least. In the summer. In fact, I actually liked some kind of haircuts that are not this way, but yeah. Okay, so let's start today. So, in question. Today, what are we going to talk about? Okay, today we're going to talk about, one, gravity. Gravity is pretty obvious, by the way. Gravity. How it is obvious. Sometimes you don't know. Okay, I'll draw a simple drawing to figure it out. Okay, so there's one big planet here. Let's say this is Jupiter. No, because it has too many moons too. Also, it may have more moons than we actually think. Anyway, so let's say it's the Earth. It only has one moon. So let alone. Alright. So you see how the moon is orbiting around the Earth. Do you know why this is so? Okay, let's say that the Earth is on a very tight fabric, a space fabric. And this is how a lot of scientists put it. But yeah, so let's say there's a giant space fabric right here. And the Earth is about to land on it. And it lands plop. Okay, and if it's not hard cement or something like that, it will not crash and break into a million pieces. Nope. And two, it will not stay still. It will sink. Okay, let's do a little bit experiment. Okay, a little bit of an experiment. Okay, I have this blanket. It's right here, so it's a little bit up on the surface, not on a surface. So it's a surface now, like this. All right. Okay, it's a surface, and what do you think will happen if I put this ball pen here? Okay. There's my fabric all over here. So here is the fabric. Now, okay, I'm holding it with my legs, but anyway, we have space. Oh, you can't see it, right? All right. So now you can see the surface. Now, I'll put the ball pen on the surface. What do you think will happen? Okay, I put it here. Did the ball pen just... I can't see it. Okay, the most bad experiment is when you can't see what's happened, which is very disappointing. Alright, so let's just say there is a fabric. Let's not show that fabric. There's one fabric. And fabric is not solid. Okay, it is a solid in scientific matter, but yeah, it bends, right? So let's say there's a fabric right over here. And now, plop, the ball pen lands. And then it will sink. it will depend on the weight. So there is this piece of paper. Let's say it's fabric. And the ball pen falls on it. Look, look. Oh, we can use this paper instead of a fabric. Right, this paper is perfectly fine. Let's say it's just a space fabric. And then something falls on it, a ball pen. It slides. But let's say there's still a hand there. Let's say there are 3 hands. One hand puts it on here, and one hand holds it. Okay, so the ball pen is still balancing, but do you see how it curves? Like a part of a circle. You see? Well, that's what I was trying to explain. It sinks up. But a space fabric, it doesn't have a limit. It's endless. See? This is how a ball pen works. Okay, but a ball pen is not round. So what happens when a ball falls? A ball will still have some surrounding it. So instead of the ball pen like this, it should be this, and then the ball pen landed, and now it was this. Right? Remember? Alright. A ball falls. You'll be still like this, except the line here will be stuck in it as well. So the ball doesn't have this side. It also have this. And also, in space, it will just end on forever. So what do you think will happen? It will sink in a ball pit. But when it sinks, there will be at least a little bit left on the outside. So I'll draw another drawing. There's one oval shape. And then it falls on the space-time fabric. Let's say this is the ball pen. Not very clear. It should be a little bit curved in a straight line. But just get this. And now, a ball, we're looking up. We're looking up from the space fabric. And now we're seeing the ball. Okay, so this is the ball. This is the surrounding pit. If the pit is this size, the ball will be about this size, leaving a little bit up here. And what if something falls inside the part that's empty? That doesn't have it doesn't have any ball in it. Or we put one ball in. Probably because it's round, it will circle and circle and circle and circle and circle and circle forever, eternity, which happens exactly. Also, we will talk about later time about wormholes, which will be also used as space fabric. Space fabric. Today we learned about space fabric and gravity, but 8 minutes and 48, 49, 50 seconds. Do you actually think this is enough for one video? Okay, so I'll explain some more. Okay, but enough of science. Space science especially. I don't do any kind of biological science. If you want to learn it, just learn it from my brother, who needs 6 years to be as grown up as me. Because he's 4 years old and I'm 10 years old. In fact, in American age, I'm 8 years old and he's super intense. Like 4 years old. I mean 2 years old. Bummer in the summer. So you have to wait 6 years, America or Korean or not, for my brother to explain about any kind of stuff he puts up on YouTube. So first, I'm just gonna say, my brother, 6 years. What's this? What's this subject that you clearly know about? And who is the scientific twin of science? Yeah, that's right, math. But do you actually think math is something like this? I'm boring away on some kind of page called a math book, and it's the horror of my history. Nope, that is not math, because math is super simple. I'm scratching my head. Ah! I can't seem to know what's 2021 multiplied by 5026. Do you think this is math? Do you think calculating is math? No. All you need is calculators. I think calculating is a waste of time. Except that you don't like let calculators at school. Really? Because we can have time for some fun things. Some actual fun things to discuss with. Such as math. So boring. Is it? Okay, so the numbers look super different. And in the old days, no parents help. If you look into a math book, you'll probably see calculations. Calculations are not math. There are specific kinds of math. But the thing I'm most obsessed with is called patterns, regulations, rules. No school rules. No food fighting, not like these rules. No talking, not like these rules. Even though I'm not a very quiet person, I'm not a very good talker. I have a lot of friends at school. Anyway. And also, there's nothing like losers table in my school. So don't think that I'm in the losers table. Even if I'm in the losers table, I don't care. So, yeah. So math is not for losers. Math is fun. It's like a board game, an unlimited board game. Calculations. Don't think about calculation. Alright. Okay. So, right now, I'm going to explain one thing. Priorities. Boring regulations? No, not like that. Regulations you can actually keep. This golden ball. What size is it? Okay, you might not say, I need a ruler. Do you? Okay. Am I going to cut the golden ball? I don't think it's going to be cut, even though it's not actual gold. But, yeah. Okay. And slowly, I put the golden ball in. I let the scissors calm down, and I pick it up. If it's right. Alright, good scissors. Good pair of scissors. Now we exactly measured that in size. How can it be so easy not to use millimeters, centimeters? Because this is not actually measuring exactly in centimeters or millimeters or meters or kilometers, but it's measuring. You can also use this as a compass. You don't need to know what centimeter it is. For example, you need to draw a straight line, which is the exact line of here to here. All you have to do is put a ruler in it, or put something like this here to measure it. Okay, let's say I need to do this. I measured it. All I need to do is draw a line with a ruler. I don't need centimeters or millimeters or meters or kilometers or miles. Nothing like that. I don't need anything like that. All I need is a pair of compass or scissors. Also illusions. Pow, 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 pow. Yeah, but it's still dangerous scissors. Anyway, did you just see? You can measure with scissors. I measured my hands. I put a dot and a dot. I put that dot in a straight line with a ruler. Oops. I have a long line, which is the exact. You say. Still not hearing anything because you're not in my house, or this doesn't have a recording set, so you can't answer any of my questions to you. Okay, so I'll answer. Still waiting for an answer. Maybe a ghost will come. Alright, I'll just talk. I got the same length of my hand with a pair of scissors and a ruler, which doesn't have any millimeters, centimeters, inches, kilometers, meters, point, on and on. Nope, it doesn't have anything on it. And yet I measured my hand. This is the wonders of math, man. And also, try to find patterns in your life. Also, oh yeah, I got a quiz for you. What's the pattern of this? 1, 2, 4, 4, 9, 6. 1, 6, 8. What's the pattern of this? I'll just explain this and go. Okay, did you realize that these are like separate numbers? So maybe this will give you a hint. 1. Okay, what did I say? 1, 2, 4, 4, 9, 6. This has a pattern, which is the same. Okay, so divide this. Okay, any dumbhead will realize this. 1, 2, 4, 4, 9, 6. Maybe it's not mirrored, but yeah. So anyway, it's 1. And 1, 4, 9 is like, yeah, squared. 1 multiply 1. 1 times 1 equals 1. 2 times 2 equals 4. And 3 times 3 equals 9. Also, you can just say that it grows with 3, 5, 7, 9, like, yeah, the exact order of odd numbers. But, yeah, I just put it that way. Squared numbers. And then 2, 4, 6. This is just, yeah, even numbers. So, bye. See you later on the next video.